Good evening to one and all. I'm Dr.Vetrivelan, working as Associate Professor in the School of Electronics Engineering at VIT University, Chennai campus. Today we shall discuss on 5G wireless and mobile communication. Let us consider the usage scenario with respect to everyday's user access pertaining to wireless networking. Let's see, with respect to internet access through Ethernet, we have a limitation of cable connectivity, whereas this could be replaced by Wi-Fi. So this gives you high level of freedom of mobility without restriction of the wired wire or in terms of the length or any other physical infrastructure. We could able to freely access the internet stuff. So this is what one of the general example where the people migrates towards wireless setup. With respect to in the office, or house, we could connect it through access point through maybe a mobile or maybe a laptop. As long as we are in the coverage of Wi-Fi, let's say we are within the office or within the house, so we could able to stay connected with the Wi-Fi. As once we started to move away from the house or office, we will be able to connect through other cellular network like a 3G and 4G. We have certain services like vehicle adapt networks. On the move, even then the user moves at the vehicle speed, still we will be able to stay connected. So these are the perspectives we have to talk in terms of wireless networking is concerned. With respect to any conference hall or airport or any public meeting, so we could able to see the real usage of Wi-Fi access rather having Ethernet based access services. Let's talk about the evolution starting from 1G till 4G. So 1G, that is, we have a analog mobile phone system in the early 1980s. We have a 2G in the 1990s later. We have a 2.5G GPRS. Then we have HSPA, that is 3G. We have a 4G, that's LTE advanced. We have a 5G expected by 2017 in Indian market. So let's see about the outlook with respect to wireless roadmap. We have with respect to 1G, that is AMS, analog mobile phone system, with respect to data rate of less than 1 or 2 kbps. With respect to GSM is concerned, it gives the maximum data rate of 9.6 kbps. Whereas the next level, that's GSM, comes under 2G. We want the limitation of GSM is we have what you call enhanced voice quality, whereas the data services limits to only SMS, maximum of 160 characters. Whereas we are looking towards data service provisioning. So henceforth we move forward 2.5G. 2.5G, good example technology is GPRS, General Packet Radio Service. So this provides a data rate of 10 times greater than the GSM. That means around 110 kbps data service provisioning was ensured by GPRS. Still people are not so happy about data service supported by GPRS. Therefore they move towards the upcoming evolution like 3G. Basically this has come from release 99 UMTS, which is going to be an upgrade core of edge technology. Then we have a LTE advanced. In early to this LTE advanced, we have a high speed download packet access, high speed uplink packet access. Altogether we have a HSPA. So then we have a LTE, long term evolution, so which is going to be a key component for the 4G. We have LTE advanced, this is announced as 4G element. So then we are the footpath towards 5G. Whereas with respect to at the parallel stream, we have a setup, technology have come in the wireless sector also. Like we have Ethernet. The next level is called wireless LAN 802.11. We have various derivatives of the wireless LAN, that is 802.11a, 802.11b. We have a G, that is called Wi-Fi, wireless fidelity, maximum of 54 Mbps. Likewise, we have a various hybrid combo like AC, 802.11a, 11 AC, AD, then N. These are all the sample wireless technologies also illustrated in this roadmap outlook. Let's quickly have a focus on various generations, that is starting from 1G. So we have mentioned 1G, that is AMS, analog mobile phone system, which gives maximum of 1 or 2 kbps. The biggest limitation or a drawback with respect to AMS was the size, and the quality of voice was very poor. Therefore, we moved towards 2G, that is global system for mobile communication, that is GSM in short. This has come from ETSI, European Telecommunications Standard Institute, in the year 1980. Later, in the 1983, it became standardized technology, that is called GSM, in the year 1983 from the same ETSI. We have 2.5G, that's for data service provisioning. GPRS has come. Then 2.75G before reaching 3G, that is Edge, enhanced form of GPRS. We have a 3G UMTS, HSPA, wideband CDMA. Then we have a release 9 of UMTS is known as LTE. Then we have some of the other advanced LTE technologies, that is LTE advanced. This is what the technological growth from cellular side, whereas at the same time from Ethernet we have moved to 802.11, that is WLAN. From WLAN for getting mobile metropolitan area network, that is MAN. We have 802.16, that is WiMAX, wireless interoperability for microwave access. This gives last mile connectivity with the support of point-to-point as well as point-to-multipoint link support. It also supports non-line of sight. We have looking for a 5th generation system, that is going to be 5G, which works based on millimeter wave communication. So this ensures to provide data rate of in the order of gigabits per second. Let's talk about with respect to sample technologies. 1G, that is AMS, 2G GSM, GPRS, that is comes under 2.5G, 2.75G, that is Edge, enhanced data rate for GSM evolution. We have enhanced data rate for GPRS evolution as well. We have a wideband CDMA and UMTS comes under 3G. HSPA, HSDPA comes under 3.5G. So UPA and optimized packet access comes under 3.75G. We have these things comes from 3GPP partnership project, the third generation partnership project. We have 3GPP2 also, third generation partnership project 2. From there only we have LTE version have got announced. Let's talk about third generation. That is example, we could see the maximum data rate of 384 kbps when you are in a move. When you are static, it ensures to provide maximum of 2 Mbps. So good example technology is HSDPA, high speed downlink packet access. So we could see the a sample Samsung mobile phone which supports 3G. The next level is 4G. So it was developed in the year 2010. It is faster than 3G, definitely. It supports data rate in the order of 100 Mbps when you are in the move. When you are static, it ensures to provide 1 Gbps. So this completely supports IP core, IP to IP, and enhanced seamless support across heterogeneous networks. So we could see the very thin gadget which supports 4G. So recently we have a 4G GeoSIM which talks about 4G communication. We have a 5G. We could see the technology, the enhanced technology very thin, sleeky. So this supports the data rate 10 times faster than the 4G. So it is in the order of 100 Gbps, starting from minimal 1 Gbps. We have, this is to be expected to land up in the Indian market in the year 2017. The outline for the 5th generation, or in short 5G, it supports mobile broadband technology, that is early stages of works and likely to be placed 6 to 7 years from now. 5G will be able to handle 10,000 times more call and data traffic than what currently supported by 3G and 4G. Data download aspects is concerned, the speed on 5G networks are likely to be several hundred times more than 4G. 5G mobile technology will change the means to use cell phone within high bandwidth. The benefit, brief idea about 5G. The current status of 5G. It is European Telephone Standard Institute formulating 5G standard, and which will be formalized by 19 by a set of telephone companies like Nokia, Ericsson, NTT, Docomo, Samsung, Huawei. These are all the company will drive this 5G related innovations. People will be able to experience with 5G, that is in the year 2020. It will be rolled out commercially in the year 2020 and 2025. Global standard are finalized by 2019. The earliest commercial deployment could be happen in the year 2020. 3G and 4G handset does not support 5G. Whether this will support 5G is the question. No, 5G requires a new chipset and devices capable of supporting speeds upwards of 10 gigabits per second. 4G and 3G ran at fractions of this speed. Therefore, it's ruled out. We cannot have 5G support with existing mobile phones. The comparison wise, if we could see, the 5G will be going to take part in the marketplace the year 2020. Data rate in the 1 Gbps and higher. The technology 4G plus quad W, that means wireless World Wide Web. Whereas 3G, 4G are concerned with respect to unified IP seamless support. Multiplexing, we have a CDMA, we have core network with respect to internet. Services are concerned, almost till 4G maximum we will have a enhanced quality of voice as well as data, whereas the 5G dynamic information access with respect to variable devices with artificial intelligence AI capabilities. That is how the intelligence could be incorporated or augmented in the mobile phone gadgets. 5G roadmap. We have the millimeter wave communication, that's going to be a spectrum used in 5G communication. This could be nomadic nodes, inclusive of even on the move road, bus stopping, lamp post, any parking area or in a building. So this will be more dense and moving network, multi-hub wireless backhaul. Even in virtual line MIMO, massive multi-antenna systems is incorporated. So basically it uses a device-to-device communication. What will 5G look and feel like? Some technology features being considered are, it uses millimeter wave, massive MIMO, multiple input, multiple output antenna, native support for IoT, Internet of Things or machine-to-machine communication, Wi-Fi first networks, virtualized network functions and software-defined networking like SDN and cognitive radios, device D2D, vehicle to everything, broadcast network, privacy by design, spectrum sharing and splicing is supported, seamless networking within licensed and unlicensed spectrum bands, service creation time reduced by 99%. Some of the performance goals of 5G under discussion. The average 300 to 500 Mbps and greater than 10 Gbps for our motto. Less than 1 millisecond latency, and almost 100% network coverage, 1000 times reduction in power, very high reliability and all circumstances, especially indoors, deep indoor coverage, that is plus 20 dB, 30 times higher device density, 10 to 100 times connected devices, 100 times average data rate, significantly higher security requirements. So the 5G challenges, traffic volumes are keep increasing with respect to 1000 times. Massive devices are connected, use cases, requirements are keep upgrading. We have a MITS 5G scenarios, that is mobile and wireless communication enabler for 2020 information society. That's what in short called METIS. So 1000 times more than the data volume, 50 to 500 billion devices, up to 10 gigabits per second, few millimeter end-to-end connectivity. It will take the lifetime of the battery could be of 10 times longer than current low power support. So this is what the future integration could be of 3G, 4G and Wi-Fi. So we'll have a great integration of access technology into one seamless experience. That's what revolution, evolution, complementary to new technologies. The requirements are data rate, capacity, spectrum, energy, latency reduction, device-to-device capability, reliability, coverage, battery, devices per area. So these are the requirements by METIS. So with respect to ultra dense network, these parameters are concentrated. Ultra reliable communication, these are the things. Massive machines, the other parameters are focused. Applications, wearable devices with artificial intelligence capabilities, 5G iPhones with 6th sense technology, global networks, VoIP enabled devices, radio resource management RRM, media independent handover. These are the application focused area where the 5G is going to focus on. And a big scale, big picture, people and things are going to interact with each other. So that's how the Internet of Things have come forward in order to deal the various domains like smart grids, EL, connected houses, connected cars, or smart inclusive of smart car, entertainment, inclusive of all the fields. That's what we call it as Internet of Things. Internet connects people and people over an internet, whereas Internet of Things, IoT, connects all things, so it is called Internet of Things. In the way back, IoT is the connected connection of everyday object with embedded computers, sensor and actuators. So whereas by 2020, by Cisco expectation, there will be a 50 billion devices connected over an internet. So opportunities are very high. So communication, we have a managed domains like connected cars, secure, connected medical, connected industries, connected vehicles, retail. So these are the platform where application domains where intelligent systems for a more connected world. So the looming opportunity with respect to internet era is concerned: consumer electronics, retail, medical, military, industrial, automotive, environmental and agriculture. So these are the fields going to play a vital role. With respect to connected cars are concerned, backbone technologies, vehicle ADAC networks, meaning that every vehicle is equipped with 802.11p, that is wave, wireless access for vehicular environment. So that is what the 802.11p enabled onboard unit. Every vehicle equipped with this onboard unit, vehicle to vehicle communication is feasible, whereas we will have one more unit maybe with LTE or WiMAX, that is what we call it as roadside unit. So the things are feasible to have vehicle to vehicle communication as well as vehicle to infrastructure or roadside communication. So therefore the emergency notification and other traffic regulations on the fly dynamic update could be driven so that the road travel could be more convenient. In order to have architectural layers, like we have a 5-layered approach. We have a sensor, it's called a data collection layer with respect to embedded boards associated with the setup sensor. Then we have a transport layer through networking, maybe through Bluetooth or maybe through Wi-Fi shield or any other networking stuff. Then next layer is called application. We have a middleware through cloud or any information processing layer. And the fourth layer could be finally application layer. So any of the application can be focused. Example, environmental monitoring, intelligent traffic. It goes up inclusive of intelligent agriculture. The research directions are could be of 5G networking with IPv6, wireless body network based healthcare, intelligent transportation. We have a wireless sensor network with localization and tracking in IoT, smart metering, smart grids, smart precision controlled agriculture, industrial IoT, industry 4.0, IIoT. Let's have a 5G is going to be a backward compatible with the technologies starting from 2G. So let's focus stage by stage, starting with the 2G. So 2G, second generation system, we have a GSM, GPRS, that is GSM and comes under 2G, GPRS comes under 2.5G, that is general packet radio service. 3G, we have a UMTS. In prior to 3G, we have a 2.75G, that is Edge, enhanced data rate for GSM evolution. So let's primarily focus on a GSM. We have a global system for mobile communication, that is 2G GSM. Let's talk about the GSM architecture, GSM protocol stack, GSM services, GSM handover, GSM security. These are the. With respect to overall cellular system, we have a so-called cordless phone. We have a PSTN network, public telephone switching networks. We have all the MSCs, that is mobile switching office, MTSO or MSC mobile switching center. We have a BTS, that is base transceiver station. That's nothing but your tower with respect to layman terminology. A user mobile phone or a device with wireless, it's moving. This is what the overall scenario. Whereas when the user is going to handle the traffic, it is not only traffic alone communicating. In order to have a established communication of traffic, means voice traffic, we should have a signaling network also takes place in the back end. So with respect to call stages are concerned, we have the first step is to talk about mobile unit initialization, meaning that as and when you switch on your mobile phone, the mobile phone sync to your highest signaling tower. That means the strongest signal it will probe nearby, then it will connect to that particular tower. That is what it is, mobile unit initialization. Scan and select the strongest setup control channel. Automatically selects appropriate base station antenna of the cell and say to identify user and register location. Can repeat to allow for movement. That means on the move, the change of cell is possible. Whereas the next step is request for a call. So once you have been connected with the tower, you are ready to use the cellular system, meaning that you can be connected through this network to anyone. You can converse, request for a connection. I'm just start dialing someone. So in that case, this is called a mobile originated call. The mobile originates, I mean mobile called unit types the callee number and starts connecting. Check the setup channel, monitor forward channel and wait for idle. Send number pre-selected channel. That is what happening in this stage. Once you start calling, that it goes to MTSO through this tower, BTS base transfer station. Then MTSO will locate where the called unit is based on callee's call. So that means MTSO does the paging It attempts to connect the mobile unit. Paging message sent to all the base stations depending on the call number. Paging signal transmitted on the setup channel. So that is what MTSO does, paging. Only one of the appropriate called unit will respond back to MTSO. So now both are get connected through uplink and downlink. Whereas the next step is ongoing call. It is keep continuing. Once the user, either a called unit or a callee, moves from their coverage of the cell, it will be called AND off. That is what is called AND off. Mobile unit moves out of range of cell into another cell without any interruption. The service will be transferred from one cell to another cell. We have other functions like call blocking. During mobile initiate, all the traffic channel may be busy. That time once you start calling, even though user are not busy, it is called due to network, it is called blocking. Call termination, user hangs up, call drop can happen due to the speed or unavailability of the network. So this is what the operation of the cellular system in terms of the all aspects. We have a control channel in order to establish and maintain the calls. We have a traffic channel to carry voice and data. This is what evolutionary path. With respect to GSM, that is in the year 1983, 900 MHz system by ETSI, that is European Telecommunication Standard Institute. We have 1987 with respect to 1800 MHz system. So let's talk about quickly on the various frequency spectra used by GSM. This is basic 900 MHz series. We have 1800 MHz series, that is digital cellular system. We have 1900 series followed in Japan, that is PCS, personal communication system. We have a uplink and downlink, that is from mobile phone to tower, that is uplink, that uses 890 MHz to 915. So the range of 25 MHz, leaving 20 MHz got band. We have 935 to 960, the difference 25 MHz used for downlink. This is what the GSM 900 follows. Similarly, with respect to 1800 GSM series, UK follows 75 MHz for uplink, another 75 for downlink. We have that is this 1800 GSM technology is known as DCS, digital cellular system. We have a GSM 1900 series, that is 60 MHz for uplink. We have 60 MHz for downlink, that is PCS. I was told already, uplink, that is nothing but between mobile handset to the tower, that's uplink, uses 25 MHz, that is from 890 to 915. Altogether we have 25 MHz. We have downlink, that is from tower to the mobile, we use 935 MHz to 960 MHz, that is altogether 25 MHz. We have each with 200 kHz carrier. We have a totally 125 channels in the uplink side. We have another 125 channels on the downlink side. So this is how the radio link aspect works. So with respect to digitalized voice could be digitized and source coded, and channel must be coded. Then we have interleaving, that is burst bits. We should have a guard band. We have a ciphering, that is for network security, that is using A3. We have a bus formatting, that is packetizing. Then we have to modulate and getting transmitted from transmitter antenna. And the called module, that is this is callee, this is called module. Called module does the reverse process. Here demodulates, reverse process of modulation. Here deformatting, reverse process of burst formatting. Ciphering, that is encryption, here is deciphering. Here de-interleaving, it's leaving of the interleaving bits. Channel decoding, source decoding. The receiver could intercept the voice. This is a uplink and downlink paired channel. So we have already informed there are 25 megahertz each with 200 kilohertz. We have 0 to 24, that is 125 channels for uplink, another 125 channels for downlink. Each 200 kilohertz we have 8 slots. There are total time period of 4.615 millisecond. With respect to one time slot burst, we have a tail 3 bits, user data 57 bits. We have a S1 bit, training the S 1 bit flag. We have a training sequence of 26 bits, user data. This is how the GSM time slot normal burst form. We have a GSM, basically time division multiplexes. We have a 124 radio carriers, inter carrier spacing of 1 slot with the 200 kilohertz, 890 to 915 uplink, 935 to 960 megahertz for a downlink, that is base to mobile. We have 8 channels per carrier. So when we look at as whole, this FDM, and internally every slot is time division multiplexing. Therefore, it uses both TDM, combinedly uses FDM and TDM. Architecture is concerned, we have the cell coverage is hexagon, not a square or a rectangle or a circular, because all these three patterns having disordered, we could not have a coverage of entire region. So therefore the preferable cell shape is hexagon. So this is what center of the hexagon we will be installing deploying the tower. So we could able to cover as much area according to our requirement. That is how the deployment takes place. This we call it as BTS. We have a set of BTS under the control of BSC, that is base station controller. We have a set of BSCs reporting to MSC, that is known as mobile switching center. Here is called base station controller set, that is controls the set of BTS, that is base transceiver station. We have similarly we have set of BSCs reporting to MSC, that is mobile switching center. Set of MSCs reporting to GMSC, that is gateway MSC. We have a VLR visitor location register and HLR home location register in every MSC. We have a operation and maintenance center in every BSC. We have a authentication register and equipment identity register, that is in concern with every MSC. We have a public switched telephone networks, have a merging of landline cable to the MSC through JMSC. This is what the overall architectural elements of GSM. So the same information is represented in the different form. We have a wireless interface that is between mobile phone to tower, that is UM interface. We have other two wired interfaces, that is A-BIS and A. A-BIS lies between tower and BSC. A interface lies between BSC and MSC. So the rest of the elements is covered already in the earlier slide. The same information. So the overall architecture could be categorized into three sections. We have a radio subsystem covering of your mobile station and base transceiver station, that is BTS, and BSC. BSC is nothing but base station controller. So the BTS and BSC, it consisting of BSS, base station subsystem, whereas from MSC onwards inclusive of VLR, HLR, so we have a NSS, network subsystem. We have a equipment register, authentication center, operational maintenance center, that is covered in operational subsystem. This is what mobile unit, that is portable one, which carries SIM card, subscriber identity module. We have SIM card functions with respect to permanent number as well as removable data, TMSA. We have a IMSI number, we have MCC, MNC, we have a number of digits for a MCC mobile country code like +91. We have a mobile network code for a appropriate type of network. We have a MSIN, that is mobile subscriber identity. So identity of HLR within the home P element. That is with respect to IMSI, International Mobile Subscriber Identity. Whereas MS, Mobile Station Integrated Service Digital Network, MSISDN concern, we have a country code, we have a national destination code, we have a mobile subscriber national definition. We have a description of the stored SIM, that is MCC. We have a like this code, India we have 405. So we have a MNC 7172 vital. So 3 digits, that is with respect to SIM card information. With respect to network, we have a +91 for India, 001 for US, 33 for France. So that's how we will store the network numbers. That is how IMEI number. To get IMEI number, star #06#. This is called BTS, that is tower by layman terminology. So this is possessing both transmission functionality as well as receiving functionality. Altogether we call it as transceiver. It does received message transcoding, voice encryption and decryption, signal processing functions of the radio interface, uplink radio channel power measurements. We have a set of BTS reporting to BSC, that is provides all the control functions and physical links between MSC and BTS. It provides external interface ABIS. We have A interface towards MSC, monitors and controls several BTS, management of this radio channel interface, alarm, handling of the external interface, performing intercell handover, switching from ABIS link to A link, interface to Operation Maintenance Center for BSS management. The next module is Mobile Switching Center, MSC. Performs call switching, interface of cellular network to PSTN, routes call between PLM and public line mobile network and PSTN, queries HLR when calls from PSTN to mobile user, inter BSC handover, paging, billing. The next entity is HLR and VLR associated with the MSC, that is home location register. It is like a database. It stores user data of all subscriber related to GMSC, International Mobile Subscriber IMSI, users telephone number MSISDN, subscription information and services, VLR address, reference to authentication key, referred when call from public and landline. The next database is VLR, Visitor Location Register. Database that contains subscriber parameter and location information for all mobile subscribers currently located in geographical area controlled by that VLR. Identity of mobile subscriber, copy of subscriber data from HLR, generates and allocates temporary mobile subscriber identity, location area code, provides necessary data when mobile originates call. Authentication center, that is stores subscriber authentication data KI, copy of is stored in SIM card, which generates signed response SR yes, generates a key pattern cipher key, random key, signed response and cipher key to the HLR on the request. We have equipment identity register EAR. It is a database that contains a list of all valid mobile equipment within the network. 3 database, whitelist, blacklist, graylist, related to all known, all bad or stolen handsets, graylist, observation. Location area update. Let's move on to channels. We have two set of channels. One is traffic channel, other one is control channel. Under traffic we have a 9.6 for the full data rate, divided by 2, that is 4.8 for kbps for off rate. We have a control channel categorized into 3 groups: broadcast channel BCH common control channel CCCH, dedicated control channel DCCH. We have a set of channels for uplink and downlink. In the downlink, we have a synchronization channel, base station control channel. So let's talk about signaling and traffic channels. That is frequency correction channel, synchronization channel, broadcast control channel. These three comes under broadcast. Common control channel, paging channel, random access grant channel comes under common control channel. Under dedicated control channel, we have a slow associated, fast associated, standalone dedicated control channel. Traffic, we have a traffic full rate, traffic off rate, EFR. These are the channels. Now move on to protocol stack. In telecommunication system, signaling is required to coordinate the necessary distributed functional entities of the network. The transfer of signal information in GSM follows layered OSI. So we have a layered stack. We have a mobile station, that is handset. We have a BTS, BSC and MSC. MS mobile station is going to be having single stack, whereas MSC is going to be a last element, that is end element in the network, that is also here having single stack. Whereas the intermediate element, namely tower, that is known as BTS, base transceiver station, and BSC are the inter-level elements, that means which is functioning in between the elements. Therefore, BTS and BSC should have dual stack, meaning that BTS is sitting between mobile station and BSC, so therefore it should have a functionality of both the forms. Similarly, BSC is sitting between BTS and MSC, so it should have a format support of both. Therefore, these two elements should have a dual functionality. With respect to physical layer, all handles the radio transmission. With respect to data link layer, link access protocol data, that is what L2 layer with respect to SS7 and message transfer protocol. Whereas L3 layer in terms of the network resources, mobility, code format, call related messages between various network entities. So this is what L3 layer basically handles call management, mobility management, radio resource management. So the same it is in terms of the OSI wise. So these are the interfaces. UMS air interface, ABIS is wired interface between BTS and BSC, A is A interfaces between BSC and MSC. So layer 1 does GMSK, that is modulation technique. What we follow is GMSK, which is nothing but MSK, minimum shift keying plus low pass filter. Channel coding, block code and convolutional codes, interleaving to distribute burst error. Power control methodology is incorporated in the physical layer functionality to minimize the co-channel interference. Time synchronizations. With respect to DLL, we have a traffic and signaling that is takes place with respect to L2 layer, whereas it is LAPDM, that is link access protocol for data network. L3 layer deals about radio resources, mobility, data form, code format, call related functionalities. So it supports radio resource management, mobility management, call management. So radio resource management handles all procedures necessary to establish, maintain and release dedicated radio channels, channel location, handover, timing advance, power control, frequency hopping. Mobility management, location management and security comes under mobility management. Involves procedure for in terms of in coordination with the HLR and VLR. Security involves authentication of mobile. So these are the mobility management services. Connection management, call control sublayer, supplementary service sublayer, short message sublayer. These are all the information relating to layers. Now moving on to GSM services. We have a 4 classes of service. One is bearer service, teleservices, supplementary services, value added service. First 2 are mandatory, whereas third one is SMS, fourth one is other value added service like a railway inquiry. We have a call, hold, speech, short SMS, facsimile. Call related, we have a call forwarding, blocking, barring, ongoing call, line identification. We have SMS that is handled through your separate SMS center, that is a part of your every base station. There is no involvement. There is no involvement of control data channel. We have a separate short message service. We have a MOC, mobile originator call, and mobile terminator call. So mobile originator call, user mobile connection request, then we have a security checks, then it goes and close circuit. That means the called unit may be landline. Whereas with respect to the same base station, we have a persistent mobile unit dials, channels the request, immediate response from base station subsystem, that is BTS and BSC, which in turn call management request was initiated by mobile station to the MSC, that is carried. Authentication procedure was done. Ciphering procedure was initiated. Now sending number of the call. So now MSC will take IAM request, that is initial address message, call proceeding. Now it's ringing. Assignment procedure, channel assignment procedure was initiated by MSC. We have an address complete message, alerting, the other end is ringing. We have ANN, answer message, connect. Path was established. Now connect acknowledgement. These are all the steps with respect to mobile originating call. The called entity is a landline here. Call initiation was the mobile phone. Mobile station, mobile terminating call, MTC, which is nothing but received entity is mobile. Call was initiated by landline. That is landline starts calling, that is forwards call to GMSC, GMSC in turn to MSC, MSC in turn does the paging. Appropriate base station subsystem will reply based on response what got from appropriate called entity. In the same way, in the reverse direction, the circuit closes. Paging, authentication, ciphering, equipment validation, call setup, handovers, call release are the major functions of call terminator call. Mobile terminator call. So this is how we have a mobile landline is the answer, initiate the call. We have a, let's see what is the procedure to be followed. Sending, routing, provide IMSC, then getting reply MSRN, routing information, then IAM MSRN, then getting paging reply. We have a paging request. We have a reply. Let's see a PSTN initiate the call, paging request by MSC, channel request, immediate channel assignment, call management service request response, authentication procedure was initiated, ciphering procedure, therefore it is ringing at the called mobile, setup procedure, connection, path established, Now we are moving on to next level, that is handover. We have two types of handover, that is odd handover, or it's called we have another is called soft handover, that is break before make, it's called odd handover. Make before break is called soft handover, that is seamless handover. We have with respect to initiation, mobile station initiated or network initiated handover. So with respect to handover is concerned, with respect to old base station, the signaling level is reducing. When you approaching the new base station, the signaling level is increasing. So we'll have to take a necessary handover margin by from there we have to take a decision. Therefore, seamless handover is possible. We have types of handover: intra-cell handover, that is within a cell. We have a inter-cell, intra-BSc, that means between cell but same BSc. That's why it's called a two different tower but same BSc. That's called inter-cell, intra-BSc. We have a one cell moved to another cell, which is different cell, true, but we have a that is truly different BSc but same MSc. That's why it's called inter-BSc, intra-MSc. We have next is intra-MSc, totally a different MSc. Naturally it will be a different cell. So handover procedure is measurement reports collected by MS base station informing to tower in turn to BSc. Handover decision is taken. The handover request must be given to new base station controller through the MSc. We have a resource allocation, channel activation. Then we have a handover request acknowledgement, handover command, handover success between mobile station from the existing BTS to the new BTS through existing BSc and the new BSc via MSc. That is how the handover process takes place. Moving on to GSM security, we have three algorithms: A3 for a secret open interface, A5 for encryption, A8 for key generation. We have this case A3 on the user side as well as network side. Signed response 32-bit was generated by the network side as well as mobile side. Both the signed response was validated and the MSc. If it matches, it allows the user to get into the network. Otherwise, denies. We have a key generation, that is through A8 random key generated 64-bit, that is to be used in both base station subsystem in order to validate the user. So far what we discussed was in terms of GSM, that is 2G. Now we have a 2.5G general packet radio service, that is 2.5G. We have existing core whatever we have discussed so far with the GSM. In addition, from BSc, that is we have a enhanced functionality like packet control unit was added in the BSc. Then we have two additional network element. One is called SGSN, other one is called GGSN. So that is SGSN stands for serving GPRS support node, that is equivalent analogy like MSc. We have another element that's called GGSN, that is gateway GPRS support node. As an analogy, it is equivalent to GMSC. So this is what the network path of GPRS. We have the GPRS network. It's closely backward compatible with the GSM. We have all the infrastructure what we discussed. It exists with respect to GSM. The add-on is GPRS now augmented. We have from BSc, that is after adding PCU, we have a SGSN and GGSN. The VLR, HLR, EAR, AUC all are shared resources. This is a pictorial view. So it allows efficient use of scarce radio resources among large number of users. So it supports data access, that is with respect to packet switching, not like a circuit switching with respect to GSM. So moving on to GPRS functionalities. Then we have next level is Edge, that is enhanced data rate for GSM evolution. We have a little more enhanced data support possible more than GSM level, and GPRS faster connection, greater data volume. With respect to GPRS, we have a 14, here is edge 48 per time slot kbps. Modulation, we have a GMSK, with here is we have 8 PSK, which with great 8 PSK we have a better data rate possible. Now moving on to 3G, 3.5G and 4G. We have a MMS, that is 3G. The important element is IP multimedia subsystem, that is as a layman terminology, MMS, mobile multimedia subsystem. We have a, like SMS, we have a MMSC, that is mobile multimedia subsystem environment. That is through this only we have MMS, video, audio, images will be sent and communicated. We have a CDMA, that's TDMA and FDMA, that is backbone access for a IMT, advanced mobile telephone 2000 standard, that is ITU telecommunication. We have a 2G to 3G, that is 3G we have CDMA, wideband CDMA. These are all the service roadmap. GSM, GPRS, we have a edge, then moved to release 99 CDMA, that is called UMTS. We have virtual home environment. We have a great support of 384 kbps when you are in moving, when you are static 2 Mbps. The SIM card must be changed from general 2G SIM to USIM. UMTS architecture, we have both circuit switching core of GSM and packet switching core of GPRS, both exist through USIM and radio network service, that is we call it as UTRAN, UMTS terrestrial radio access network, that is close analogy like a base station subsystem. Here we call it as radio network subsystem. Like equipment, mobile equipment and SIM, we have mobile station. Here is called mobile equipment with USIM. No more general SIM, it is UMTS SIM. The remaining network side we have already incorporated with the circuit switched core of MSC and GMSC, packet switched core of SGSM and GGSM. Then we have other PSTN, PLMN network exists. So that is core network, we have providers switching, routing and transit for user data. UMTS terrestrial network, that is your tower. BTS, what we call in GSM, here we call it as UTRAN. User equipment must be equipped with USIM in order to have a 3G services. So UTRAN, as we have mentioned, UTRAN, that is the tower. We have a node B, that is nothing but tower, UTRAN and RNC, radio network controller. So altogether it's radio network system. Radio network controller, it's like a BSC. It does modulation, demodulation, radio resource control, channel allocation, power control, handover, ciphering, segmenting and reassembling. We have a 3.5G with the HSPA is an amendment of two mobile telephone protocols, that is HSUPA and HSDPA. That means downlink packet access as well as uplink packet access with coexistence of wideband CDMA. We have a 3.5G introduced many new features that will enhance the UMTS technology, that is evolved data video already supports most of the features we provided in 3.5G. Adaptive modulation and coding, AMC, fast scheduling, backward compatible with 3G, enhanced air interface. With respect to 4G, we have a LTE advanced next generation mobile broadband technology, promised to support 100 Mbps all IP traffic. Advantages of LTE are high network throughput, low latency, plug and play architecture, low operating cost, all IP network, simplified upgrade path from 3G. With respect to end users are concerned, whatever I explained, that is for network side. With respect to end user, fast data download and upload, improved response for applications, improved end user experience. That is, we have a static ensured provisioning of 1 Gbps. Major LTE radio technologies, OFDM. We have a single carrier FDMA and multi carrier FDMA, MIMO. We have LTE architecture with PCF, that is point coordination radio function, home subscriber station, mobility management entity. We have a like a node B in UMTS, where we call it as evolved node B in 4G element. User equipment, we have a serving gateway, we have a paging gateway, that is all IP principle. That's how it is compared with UMTS and LTE. We have this side is UMTS, this is MME, that is PDN gateway and serving gateway. We have like a node B, here is E node B, here SGS, then we have a mobility management entity. The closer analogy to compare 3G and 4G. With respect to context, evolved hardware technologies plus improves network bandwidth leads to entertainment apps on the mobile, like YouTube, TUV, Ustream. Context, when you are not mobile, you use these. Now to end, we have a 5G functional architecture. We have a streaming server, data server, server for real-time communication, inclusive of all the 2G, 2.5G networks, 3G, WLAN, LTE. So we'll have a functional global architecture of encompassed with all these elements. We have a OWA stands for Open Wireless Architecture. This is used to be as a physical layer, data link layer. We have a network layer is divided into lower network and upper network. Network layer is used to route the data from source destination. Open transport layer from the operation of the both transport and session. Transport plus session is called OTL. Application layer marks the data into proper format. It decrypts the data which is encrypted from and selects the best wireless connection for a given service. Data transfer architecture 5G. We have a radio access network. Other side is global. We have a GSM, GPRS, UMTS, LTE, WiMAX, Wi-Fi, CDMA 2000, evolved data optimized, CDMA 1, IS95, ISP. With respect to all the radio access network, we have aggregator. We have a flatter IP networks, all IP. The other side is nano core, that is we have a all IP principle through nanotechnology, cloud, all these things are nano core. The global side perspective, search engine, defense, astronomy, transportation, communication, medical, education, government, private portal. This is what the global view of data transfer architecture of 5G. We have a radio access network with a different access technology, flat IP network through nano and global cloud computing, all IP principle. The overall, we have a OSI layer is compared with the 5G. We have an open wireless access, physical and data. We have network, lower network and upper network. The session and transportation is equivalent to open transport protocol application service. So all the network, IPv6 is the backbone for this, which supports 128 bits, 4 times more than the current 32-bit IP support. Home IP along with the CARAP address. Hardware used, ultra wideband network with the higher bandwidth at low energy levels. Bandwidth is 4000 Mbps, which is 400 times faster than today's wireless network. Uses smart antenna, uses CDMA, code division multiple access. Software used are, we have including LAN, WAN, World Wide Web, Unified IP, seamless combination of broadband, software defined radio, cognitive networks, flexibility device. Data bandwidth 1 Gbps and IO, dynamic information access, available at low cost, finest quality of service, pages will upload almost instantly, support interactive multimedia, voice, streaming, video, internet and other broadband services are the advantages of 5G. Disadvantage, since 5G services are likely to run on ultra spectrum band which travels shorter distance compared to lower bands, they may be more suited to enhanced indoor coverage. Higher frequency could be blocked by buildings and they lose intensity over long distance. That means offering wider coverage would be the challenging. Summary: 5G technology is going to be a new revolution in wireless system market. 5G will be user centric. 5G is next frontier of innovation for entire mobile industry. 5G is promising generation of wireless communication that will change the people lives. Thank you.